September 2025. Deep inside the latest imaging archive of the James Webb Space Telescope, astronomers uncovered something unexpected. The interstellar object known as 3I Atlas, only the third ever detected passing through our solar system, was not simply drifting, it was growing. Across several Webb observations, Atlas expanded in size, its outline swelling by measurable percentages within weeks. This was not the behavior of dust jets. This was not ordinary debris. It was something far stranger. If these readings are correct, humanity is witnessing the first time an interstellar visitor has changed its structure in real time, and the pace of that change is being described as alarming. The question is no longer where Atlas came from. The question is what exactly it is becoming right now. 3I. Atlas entered the solar system on a hyperbolic trajectory, slicing in from the direction of the constellation Lyra. Its inbound speed, measured at nearly 70 kilometers per second, immediately confirmed its interstellar origin. No object bound to the sun can move that quickly without escaping forever. Early optical surveys showed Atlas as a faint, elongated smear against the star field, neither round nor sharply defined. Astronomers quickly noted the difference. The first interstellar visitor, 1I Oumuamua, appeared thin and cigar-like, with a light curve that spun like a flashing blade. The second, 2I Borisov, revealed a classic cometary halo, venting gases as it sped by. Atlas resembled neither. It was dim, stretched, and strangely stable. Its name was not mythological, but technical. It came from the Asteroid Terrestrial Impact Last Alert System, or ATLAS, the sky survey program that first logged the anomaly. Yet in its form and silence, Atlas carried the aura of a true stranger, an object from elsewhere that bore none of the familiar signatures of rock or ice, a visitor unlike any seen before. When the James Webb Space Telescope was tasked with following 3I Atlas, expectations were modest. Webb's infrared instruments, NIRCam and MIRI, were thought capable of refining its shape, surface chemistry, and thermal output. Instead, they recorded something more difficult to classify. Across multiple observation windows, spaced weeks apart, Atlas appeared to grow. Its measured cross-section increased by roughly 4% per cycle, a change too large to be dismissed as calibration error. The expansion was not irregular, not the chaotic outburst of volatile ice. It was measured. Each time Webb returned to the target, the halo around Atlas had swelled further. Astronomers who first processed the data called it non-ballistic behavior. The object was not merely tumbling or venting like a comet, it was physically changing its outline in a way that seemed consistent, almost engineered. According to a preliminary European Space Agency memo, the increase was flagged as an unmodeled geometric expansion, a category with no precedent in interstellar research. The language was cautious, yet the implication was clear. Something was happening to 3I Atlas that did not fit into the physics of ordinary asteroids or comets. Webb was not merely recording a visitor, it was documenting an evolution, playing out in real time, far from the sun's furnace yet too precise to dismiss as random. Atlas was not static, it was alive with change. The strangeness of 3I Atlas becomes clearer when set against the two objects that preceded it. In 2017, 1I Oumuamua raced through the inner solar system like a shard of mirrored glass. Its brightness curve rose and fell in sharp pulses, suggesting an elongated form, thin and reflective. The lack of a cometary tail led some to speculate it was a fragment of technology, a sail pushed by starlight. 2 years later came 2I Borisov, a more familiar traveler. Its coma and trailing gases resembled a classical comet, the type long catalogued within our own system. Jets of volatile ice venting in the sunlight explained its acceleration and glow. Borisov reassured many that interstellar visitors could still obey known patterns. Atlas refuses both categories. Its speed of 70 kilometers per second is typical for interstellar wanderers, but its body shows none of Borisov's gaseous outflow. At the same time, it lacks the razor-thin reflectivity of Oumuamua. Its expansion is not the chaotic spatter of sublimation, nor the silent glide of a light sail. It is something stranger, unfolding with a steady rhythm. In scientific circles, the description has taken hold. Atlas behaves like neither rock nor comet. It occupies an ambiguous middle ground, an object that resists classification and deepens the mystery of what kinds of structures truly drift between the stars. The first line of defense in astronomy is always to assume nature. For 3I Atlas, the most immediate idea was thermal fracturing. Even at its distance from the sun, hidden pockets of volatile ice could crack and vent, pushing out faint plumes of gas and dust. Over time, this might create the illusion of growth. Another model suggested collisional debris. If Atlas had been struck by micrometeoroids during its long journey, it could be trailing a fragile shell of regolith. That cloud might expand gradually as sunlight and solar wind forced it outward, wrapping the object in a haze of its own fragments. On paper, these explanations sound plausible. In practice, they fail. The expansion recorded by Webb is not ragged. It does not follow the jittery rhythm of random gas jets, nor does it scatter unevenly like a broken rubble pile. The increase in cross-section is uniform, measured at nearly the same percentage each observational cycle. Nature is chaotic, but this growth is geometric. It is unfolding like a blueprint. The weakness of natural models only sharpens the anomaly. If gas jets or collisions were responsible, astronomers should see asymmetry, uneven brightening, or rotational wobbles. Instead, they see smooth curves and repeating numbers. Graphs of its profile do not look like noise. They look like a function being solved in real time. Nature is messy. This growth is mathematical. Once natural mechanisms falter, speculation inevitably follows. The conversation is not about aliens in the sensational sense, but about engineered structures in astrophysics, the kinds imagined in theoretical papers. One possibility is that Atlas represents a fragment of a Dyson-like architecture. Shards of thin material drifting through interstellar space could unfurl under the pressure of starlight, expanding slowly as membranes catch photons. Another is that Atlas resembles a von Neumann probe, a seed craft designed to replicate or reconfigure itself once it encounters a new stellar environment. In such a frame, the expansion would not be accidental but purposeful. If Atlas is a shell, the uniform increase makes sense. A thin membrane could be designed to spread as it absorbs energy. The sun's radiation pressure, or even tidal stresses from gravitational encounters, could act as a trigger. Photons themselves might be enough to inflate a structure meant to grow only when it reaches a new system. These are hypotheses, not conclusions. They exist at the frontier where astrophysics meets imagination. Yet Webb's precision makes it difficult to dismiss them outright. The telescope has measured consistent percentages, not random bursts. That regularity forces scientists to ask whether Atlas could be more than inert matter. It is too early to declare intentions, too soon to call it a probe or a fragment of design, but the shape of the data is pressing the question. Atlas is not behaving like rock, ice, or dust. It is expanding in a way that fits no familiar category. For now, the safe answer is uncertainty. But behind closed doors, some astronomers admit that Webb may have just placed the first hard evidence of engineered change into our collective record. News of Atlas's expansion has already ignited debate. Predictably, Harvard's Avi Loeb has noted the similarity to his earlier arguments about Oumuamua, suggesting that unusual interstellar objects may represent a class of artificial structures. His comments have drawn both interest and frustration, with many dismissing the comparison as premature. Meanwhile, modelers at the European Space Agency stress cometary processes. They argue that even uniform venting can occur under rare thermal conditions. Their position is cautious, pointing to the risks of overinterpreting Webb's limited sample size. Amateur astronomers have also entered the discussion. On forums like Reddit, backyard observers claim to have seen faint fluctuations that seem to support Webb's findings. One observer from Arizona, using a modest 12-inch telescope, described Atlas as a smudge that seems to breathe. His notes are far from scientific, but they capture the unease many feel. The community is divided. Some call the anomaly a data artifact. Others see the precision as undeniable. Between the institutions and the hobbyists, the story of Atlas is already becoming more than science. It is a conversation about what humanity is prepared to recognize when the universe refuses to fit our categories. And yet beyond the debates, a more sobering question is emerging. If Atlas continues to grow, what does it mean for us here on Earth? If the expansion rate continues as Webb has measured, projections suggest that Atlas could double its apparent size within 9 months. For an interstellar traveler, that pace is extraordinary. The implications are not just scientific curiosity, but practical concern. A growing envelope around Atlas could mean a developing dust cloud. As the halo thickens, solar radiation pressure may slow the object, altering its path in ways orbital models cannot yet predict. There is also the possibility of fragmentation. If Atlas is shedding material into a broader shell, it could seed the solar system with high-velocity debris. This raises the inevitable question: could Earth cross the path of such ejecta? The probability remains low. Current models suggest no direct collision course and the distances are still vast. But in cosmic terms, low is not zero. Even a diluted cloud intersected by a planet's orbit could create a meteor storm of unknown scale. Scientists caution against panic, but the suspense is real. Atlas is no longer simply a curiosity on a hyperbolic escape. It is a variable object, expanding into a form that no one fully understands. And the more it grows, the greater the uncertainty becomes. Unusual visitors from the sky have unsettled humanity for millennia. Ancient Chinese astronomers recorded guest stars that swelled in brightness before fading. Medieval chronicles describe comets that appeared to grow tails overnight, seen as omens of upheaval. In each case, an expanding light in the heavens carried more weight than mere observation. It was interpreted as a sign. 3i Atlas now fits into this lineage of cosmic unease. Not a comet in the traditional sense, yet behaving with the same uncanny rhythm of increase. Its very name invites myth. In Greek tradition, Atlas bore the weight of the heavens. Now, under the gaze of Webb, an object bearing that name seems to carry expansion itself, stretching wider with every passing week. The resonance is difficult to ignore. Ancient observers looked up and saw growth as omen. Modern scientists look up and see growth as anomaly. Across centuries, the reaction is the same. Something is happening in the sky that defies expectation. The images of 3i Atlas collected by Webb are only the beginning. They represent a handful of snapshots from a telescope designed to see farther than anything built before. Already, the data has rewritten the conversation about what interstellar visitors can be. Other instruments will soon be trained on Atlas, ground-based observatories, Hubble's ultraviolet detectors, and radio arrays searching for non-thermal emissions. Together, they may refine whether the expansion is a natural physics process or something entirely new. Either way, the record is historic. Humanity is watching a body from another star system transform before its eyes. The safe interpretation is that Atlas hides exotic ice physics, some sublimation process we have not yet modeled. The speculative interpretation is that we are watching the first engineered expansion in interstellar space. At this stage, both remain open. The next release of Webb data is expected in 3 months. That window may confirm whether the growth trend continues, accelerates, or stabilizes. Until then, the only certainty is that Atlas is not static. It is in flux, and the universe has offered no clear reason why. For viewers, the task is simple. Follow the expansion, track the reports, stay aware of the data as it emerges. Because whether natural or artificial, Atlas is already rewriting the way we think about interstellar visitors. The 3i Atlas is still growing. The only question is why.